Good afternoon, and welcome to the final keynote presentation for the WITS Charlotte Conference. My name is Yeniko Taylor, and I am an Associate Professor and Director of Health Services Research with the Center for Outcomes Research and Evaluation at Atrium Health. I am truly delighted to introduce today's keynote speaker, Dr. Cecilia Aragon. Dr. Aragon is a multi-talented scientist, pilot, author, and entrepreneur with a 30-year career in data science and software development, spanning industry, government, and academia. She earned her PhD in computer science from UC Berkeley and her bachelor's in mathematics from the California Institute of Technology. She is currently professor in the Department of Human-Centered Design and Engineering at the University of Washington in Seattle, where she serves as director of the Human-Centered Data Science Lab, founding co-director of the Data Science Master's Program, and Senior Data Science Fellow at the eScience Institute. In 2016, Dr. Aragon became the first Latina to be named to the rank of full professor in the University of Washington's 100-year history. Her research has been recognized by numerous awards, including the Presidential Early Career Award for Scientists and Engineers, which is the highest honor bestowed by the U.S. government on outstanding scientists in the early stages of their careers. Dr. Aragon has authored or co-authored over 130 peer-reviewed articles, 3 books, 5 patents, and over 140 other publications in the areas of data science, visual analytics, machine learning, HCI, and astrophysics. Her most recent book, Flying Free: My Victory Over Fear to Become the First Latina Pilot in the U.S. Aerobatic Team, tells the story of her journey from fearful child to award-winning pilot and data scientist. She is co-founder of Latinas in Computing, an organization that seeks to promote leadership and professional development among current and next generations of Latinas in technology. She is also co-author of a forthcoming book titled Human-Centered Data Science: An Introduction. Today, Dr. Aragon will speak to us about the human aspects of data science, what it means for data science to be both rigorous and human-centered, and share her thoughts on future directions for the field. Please join me in welcoming Cecilia Aragon.
Thank you so much, Yeniko, for that wonderful introduction. I really appreciate it, and I'm truly honored to be here. It's truly a pleasure and a privilege to be here, to be speaking at the Women in Data Science Conference. I've been loving this conference so far. It's wonderful. I love hanging out with technical women and learning something about how you are all going to make a difference in the world going forward. So today I'm going to be talking about the rigorous and human life of data. And what I mean by that is, so often in my life, I've been told that rigorous, meaning mathematically rigorous, deeply technical, and human-centered are opposites. Paying attention to how humans deal with technical issues, I've been told, was soft, easy, and various other dismissive pejoratives. And I'm here to tell you that in my experience, in my 30-year career as a data scientist, nothing could be further from the truth. Being human-centered makes data science better. And it is not only possible, but really kind of mandatory that data science be both rigorous and human-centered. So I hope to convince you of that during this talk. But I want to start out by just briefly going through my career. And when I lay it all out this way, it looks very traditional, except for the fact that I did start working in what is called data science before it was called data science. With my background in computer science and statistics and math, I had all the tools necessary, and I've actually been working with what was considered very large data sets since the 80s. I started out as a practicing data scientist in industry. I worked for many companies doing creating statistical and machine learning algorithms to analyze very large data sets, dealing with high volume documents, financial data, and many other types of business documents. Around 2000, I shifted to government labs where I started working with scientific data. Again, it was very large, high volume, high velocity data, like airflow across aircraft and spacecraft, and astrophysics and supernova data. And then in 2010, I moved to academia, where I'm now at the University of Washington. And I have to say, I really have loved being a faculty member. I highly encourage it as a choice for aspiring data scientists. In my view, there's going to be a lot more faculty positions in data science opening up in the next few years. With that, I'm going to start out, since I'm talking about both rigor and human-centeredness, I'm going to take a page out of Bhavna's really excellent keynote yesterday and add some awkward childhood photos. Although I have to say, my photos are much more awkward than hers. As you can, so the ugly pictures in this image are all me, and the other ones are pictures I just grabbed off the internet. So I was a pretty awkward, homely child and extremely shy and timid. Nobody really noticed me. I wanted to reach out, but I couldn't. And it was because of fear. As Bhavna and others have mentioned, fear is a paralyzing and terrifying force. And for me, that I was afraid of everything. I was afraid of heights. I was afraid of doing anything risky, like sledding. I was afraid of talking to classmates in the cafeteria, and especially making speeches in front of an audience. That would have been completely impossible for me. So I felt like I was trapped behind a glass wall, and I would bang on it and shout as loud as I could, but nobody heard me. So even as a child, I knew that I couldn't live this way, but I had no idea how to get out. People said, well, you just need to be more confident. You need to overcome your fear, but nobody said how. So I had to start with figuring out what made me so fearful. And for me, it was my childhood experiences. I grew up in a small Indiana town, and both my parents are immigrants. They spoke with thick accents. My dad was from South America and my mom from the Philippines. And what that meant was that I experienced a lot of people dismissed me, including my teachers and my classmates. So at the beginning of every school year, even though I had a record from the year before, I was always placed in the slow reading group because, of course, a Hispanic child could not possibly know how to read well. I once remember I wrote an essay that was kind of articulate, and my teacher accused me of plagiarism because someone like me couldn't possibly know all those big words. So that teacher wasn't trying to be cruel, but imagine the message she gave that young child. And those messages can stick and can grow, and they can take root in you when you believe, oh, I am not smart enough to do math. I do not know enough. I am not that confident. So I want to encourage you, first of all, to realize that it's not your fault if you're shy, if you lack confidence. And it does not mean that you cannot be good at math just because you had one class where the teacher maybe didn't teach it well enough. Everybody here can shine at data science. And what I would like to do is share a little bit about how I got over that fear. And then I'm going to jump into talking more about data science. So how did I fight off all those negative messages later in my life? Well, the solace for me was math. So my English teacher accused me of plagiarism, but in math, if I got all the answers right, none of my teachers could mark me down. And this is one of the reasons why today I work a lot with girls and women in STEM, because there is no substitute for being comfortable with math, and you face a group of people who think little of you and you silence them with your love of numbers. Math is kind of a magic trick that way. And so I'd like you all to remember that do not ever let a screwed up system screw up your own definition of yourself. Although I blamed myself as a child and thought there was something wrong with me, ask yourself, if you lose an opportunity, is it really because of a failure that you made, or is it because of your gender or your race or some other issue? And tell yourself that you are smart enough. That is so important, that belief in yourself. So how did I actually develop the belief in myself, and how did I break free of my fears? Well, for me, it was a little different. I decided I was going to do the thing that scared me the most, and that was learning how to fly a small airplane, and even learning how to fly it upside down. And it turned out that I could use math to help me get over my fears in this, kind of terrifying field. And I'm not encouraging everybody here to take up flying or skydiving or something really risky. You really have to decide that for yourself. But I am going to suggest that you find something that makes you nervous and scared, and that you push yourself in that direction, because that will really make a difference in your life. All right, so let's get back to the human side and the rigorous side of data science. So I did end up with a very non-traditional career path. And I also want to encourage everyone who has such a path to realize that there still are opportunities for you. If you take time off to be a mother, so I have 2 children, and I did take some time off to be a mother. And you can re-enter. There are many programs now to focus on, how you can use the skills from your life and from motherhood to being really excellent as a data scientist. And so what I also finally decided, now that I'm a full professor at a university, and I love it, by the way, it's a wonderful job. But I also decided to write this memoir, Flying Free, which is about how overcoming fear was really critical for my career as a pilot and then as a data scientist. And, believe it or not, because of all this treatment that I got as a child, I was actually more scared to get a PhD in computer science than I was to point an airplane straight at the ground at 250 miles an hour and do what I felt was risking my life. I mean, that's how powerful these subconscious denigrations of you can be. And we all grow up in a very sexist society, even if it's not conscious, that there are tremendous systemic pressures on us to be less than we are. And it's really important to push beyond those. And it will take some pushing, but the advantage, of course, is that this is a wonderful job. I mean, data science is not only incredibly important, but it is fun. And you really get a feeling that you're making an impact in the world and that you're changing the world for the better. So, okay, so now I'm going to talk about the main point of my talk, which is human-centered data science. And so I'm going to give you 3 examples. These are all from my own career. And I hope they'll convince you of the importance of rigorous and human-centered data science. So the first one is just why thinking about human issues in data science is necessary, if you just look at the data. And the second one is an anecdote from my own career where I that's just one example out of many, where I talk about how data science always involves solving both technical and social issues. And you really have to consider both of them. And if you do, you'll actually be much more successful than people who only consider the technical issues. And then finally, number 3, again, this is based on data and evidence from research. The data science is human-centered, whether we believe it or not. And I'm basing this on quite a bit of research on the data science cycle and on practicing data scientists. So, all right, so let's start about, well, why is this even necessary? This is a comment that I got a lot when I was starting out in data science. And so the answer that I used to always give people, and I still give it today, is if you think about it, what is the rate limiting step in data understanding when we know that the amount of data in the world is increasing exponentially and it's continuing to do so? All right, so as a computer scientist, a lot of people told me, well, you know, Moore's law, which says that, you know, processing power is also growing exponentially, and therefore hardware is always going to be able to keep up with the data. Okay, maybe this is true. Then some people mentioned that there are problems and that the effective processing power is limited by Amdahl's law, which states that you can really only parallelize data processing so far. And so there's always going to be a little bit of a gap there. And so how are we going to address that gap? But the response that I give to that is, well, despite all this computational growth, human cognitive capacity is not growing exponentially. I mean, we're still the same people we were 50 years ago, 100 years ago, and, you know, even 100,000 years ago, more or less. You know, and so when I first drew this slide, I used to say, well, human cognitive capacity was flat. But then my kids, who were teenagers at the time, said, oh no, we're a lot smarter than you, you know, you old people, because we can multitask better. And so I said, okay, I'll give you that there may be some increase, but it's a linear increase at best. And they acknowledged that had to be true too. So, okay, so what do we do? Now we have a second gap here. How are we going to deal with that? And so my answer to this has always been, it's not that we need to stop investing in hardware and software and artificial intelligence and new machine learning algorithms, but we also need to think about human-centered data science. We need to think about building collaborative software, effective user interfaces, thinking about visualization and visual analytics. The visual channel is the highest bandwidth channel into the human brain. We need to use that. Then we also need to think about sociology and social impacts. What are the ethics of data science? Because like it or not, the software and the technology we build is changing people's lives and it's impacting everybody's life. And we really need to study that, and we need to be cognizant of what we do as data scientists and how it changes the world. That is so critical. And this is why when I was one of the founders of our data science program here at the University of Washington, I pushed really hard for a full class in human-centered data science, because there have been so many cases of data scientists really making the mistake of being purely technical and causing, you know, tremendous harms and, you know, lawsuits and various issues where things went wrong, where they didn't consider the societal impacts of their work. So this is super, super important. All right, so now switching gears to a personal anecdote from my own career. So I have found in the years that I have been working in data science, and, you know, from business cases to scientific data to government research to academia, the data science always involves solving both technical and social issues. And in every case, they have mattered. So this is an example from astrophysics, which I love because it was so much fun. So I worked on a project that was solving looking at the largest thermonuclear explosions in the universe in order to solve grand challenges in astrophysics and the nature of the universe itself. I mean, so super exciting. And when I got hired onto the project, there had already been 2 teams of data scientists and computer scientists that had attempted to solve this intractable problem these astrophysicists had, and both of them had failed. So then they brought me on and they said, all right, Cecilia, solve this problem, this $1 million problem that everybody else has failed at. No pressure. But anyway, the good news is that I was able to solve their problem. And how did I do it? It was by taking a human-centered approach to the problem. The previous data scientists had come in and said, let's come up with a requirements document. Let's think about the technology and let's solve that. And it turned out that was not sufficient. So there were actually 4 main improvements that I made to the existing software. And I'm going to talk about one of them. But before I do that, I'm going to say, why was taking a human-centered approach so important? Well, they had a big data problem. And so there's been a lot of questions about, well, what is the definition of big data? Particle physicists have always said, oh, we have it and no one else does. And astronomers also have had big data, and other fields have had big data, and no one really can quite agree on a numerical definition. And I want to say that's because you can only look at big data in a human-centered way. The way I define big data is it's 2 orders of magnitude greater than you're used to dealing with. Because when that happens, when you multiply your existing amount of data by 100, suddenly all your processes won't work anymore. Your software breaks, your daily life, it will know your work process, your business processes just will not function. So with the particle physicists with the astrophysicists that I was working with, for the Large Synoptic Survey Telescope, they are going from 100 gigabytes of data per night to 10 terabytes per night. And that meant that they had to redo everything. The particle physicists, of course, said, oh, well, we went from 200 megabytes per second to 20 gigabytes per second. And this is at the Large Hadron Collider in CERN. And if you look at that, what is 20 gigabytes per second? That's actually nearly 2 million gigabytes per day, which is the same as 2,000 terabytes or 2 petabytes per day. So you can see it's much larger in volume than what the astrophysicists were dealing with. But did this mean that the astrophysicists, didn't have a problem? No, they did. And it was because of this human-centered, overwhelming change. And so I like to, because it's really hard for humans to grasp what is a gigabyte, what is a terabyte. I really like to put it in a human context. Let's suppose your job required you to read 2 books a week. All right, that's a lot of reading, but you could do it, right? You could do that and still get your job done. But what if all of a sudden tomorrow your boss says, now you have to read 200 books a week? Okay, you can see how that change in 2 orders of magnitude means that now you just cannot do anything you've done before. You have to completely change how you look at the world, how you look at reading even. So everything is shaken up, and everything you've done before has to be really kind of thrown out the window, and you have to do something completely new. So this is what was happening to these astrophysicists when I joined the project. I'm not going to go into a whole lot of detail about this really fascinating project. Just suffice it to say, they were studying, they were trying to look for supernova, exploding stars, out of a very large number of stars in the universe they imaged every night. And it's a very challenging big data problem. And it involved collecting data on one telescope, sending it over, over fiber optic networks to another one. And yeah, it was a huge, huge effort. And then they had to process the data, and it took all night to process their data, so their computers were maxed, right? This is an important factor. And so this is image processing, but it's very large scale image processing. And what they were doing is they were to look for these supernova. I'm not going to go into the details of how it was done technically, although it's super cool, but essentially you're subtracting, past images of the sky from tonight's images of the sky. And sometimes you subtract out an image and you're left with that nice round supernova like you can see in the upper right-hand corner. But sometimes it's a bad subtraction where there's a misalignment, and you end up with something that looks like that C-shaped thing in the bottom. And the interesting part, all right, so the human-centered technique I used to solve this problem was called contextual analysis and ethnography. And what I did is, instead of just looking at the technical problems, I actually spent time sitting with the scientists and going through their daily work life. And I did this, I collected 100 hours of interview data just on their process before I wrote a line of code or addressed any of the data problems in their pipeline. And so one of the things I noticed is that they were looking at this, and they happened not to know that there's an existing image processing technique called the Fourier contour descriptor algorithm, where you can actually detect the shape of an object. And this is a mathematical algorithm that they didn't know they needed, and none of the previous computer scientists knew they needed, because they didn't spend the time actually looking at the image. It's like, we don't want to look at this, all these hundreds of thousands of images. It takes too much time, and we're busy. It's efficiency. We got to be efficient. We got to meet our deadline. And what I'm saying is, sometimes you need to slow down and do things on human time rather than only on, computational time. So by using these very human-centered sociological and anthropological techniques and applying mathematical algorithms, I was actually able to create a very fast algorithm that reduced their false positives by 41% without increasing their running time at all. And what's really interesting about this is the first time I suggested the Fourier contour analysis, they all told me, all these, and I was the only woman in the group, by the way, and they were all physicists, and they said, "Oh, Cecilia, you're wrong. This will not work because Fourier transforms are really expensive, and we do not have any extra time. You have to do something else." So it's a good thing that I developed my confidence from learning to fly upside down, and I was able to tell them, no, this is correct, and I'm going to prove it to you. I'm going to show you how to build this rigorous algorithm, and I'm going to prove to you that it has no measurable increase in running time. And that is actually what I did. And so this was just one of 4 specific changes that I made to their system that actually solved their problem. when I joined the project, they were not collecting data. Their database had, you know, their pipeline for moving data along their database had failed. And through these 4 improvements to their system, it ended up with 90% labor savings. When I started the project, there were 6 or around 6 to 8 junior scientists working 4 hours per day manually dealing with all this data. And after I finished my improvements, it only took 1 person 1 hour a day. And yes, I did apply machine learning algorithms. I did apply novel image processing algorithms, but I would never have known how to do those technical solutions if I hadn't started out with a human-centered approach to this problem. And I will say it was not easy, because I got comments like, why are you just watching us, Cecilia? Why aren't you writing some scripts? But the good news is, I have to say, in the end, all these scientists became terrific advocates. And they considered me a full member of the collaboration. And when our principal investigator won the Nobel Prize for his work, he named me as one of the important contributors. So yeah, a human-centered approach can really help you be very successful. So please, yes, be rigorous, understand the mathematics, understand the algorithms, but do not give up the human-centered approach. All right, so my third and final example is that data science is human-centered, whether we believe it or not. All right, and this is based on research looking at many groups of data scientists dealing with large data sets in business. We're often told about the data science cycle, and it's often presented as this very clean and kind of impersonal sequence of computational operations. And it's often assumed that, oh, there's no human element in the database. It's been removed. Data are unbiased. We can get those messy humans out of the way. Nevertheless, in every group of data scientists that were studied here, we found that people touch the data at nearly every step in the data science cycle. So in our forthcoming book, Human-Centered Data Science, an Introduction, we identify 5 places where humans actually intervene in the data science cycle. And I'll just go through this briefly, and I'll give one example. So first of all, discovery, data discovery. When you encounter a data set and decide to use it, well, it turns out there's a lot of human intervention. Which data set do you use? Do you repurpose an existing data set? What do you understand about the description and the provenance of that data set? It's very human-centered, and humans touch it and introduce bias or opinion or expertise into the data. Capture, the very process of capturing data, the decisions made by the software or the sensors that collect the data, well, humans make those decisions. Then there's data curation. Whenever you have a data set, it's going to be altered to make more sense to someone, right? It's brought together from different sources. And one of the most important aspects at all is data design. How do we craft or categorize data through sets of choices? And this is something, this is the example I've chosen to talk about, because data is always designed. There are always decisions made, and I'm going to show you some examples. And then finally, creation. People will end up adding values to the records in data sets through labeling. They will mix 2 different data sets and potentially create a privacy risk because of because of added data. Like if you mix zip code data with just about any other type of data, you really violate, you can re-identify the people in that data set. So, okay, so let's just talk about the design of data. So you've probably heard as data science students, you've heard about cleaning and wrangling of data. What's not as often mentioned is that is a really human activity, because you are using your human judgment as an expert data scientist to clean and fix up this data. So there's really some simple examples from scientific research, which you would imagine is very unbiased and neutral. If you have Earth samples, the scientists often use the geologists use color charts to categorize them. Species are categorized according to a previously established taxonomy. It even happens in astrophysics in the example that I gave before, where scientists actually, they label galaxies, they categorize galaxies, and they wanted to know who was the person who categorized them, because it turned out there was one particular senior scientist who categorized the galaxies and the stars in a way that pretty much everybody else disagreed with. So yes, there are human touches in the most abstract of data sets. And this is the design of data, and it happens everywhere. So one other final simple example is whenever you exclude outliers from your data set, which is something I'm sure you've all done, how do you decide the criteria for outliers? Is it truly an outlier, or are you excluding something that really is a part of the data set? You can see this if, for example, if you're launching the space shuttle and all the rest of your data says the temperature is around 25, or around 75 degrees, and now all of a sudden you have a data point at 25, is that an outlier, or is that something that you should pay attention to? All right, so I hope that with these 3 brief examples, I've illustrated to you how data science can and must be both rigorous and human-centered. So I started out talking about why thinking about human issues and data science is necessary. Just talking about how much data there is and how it's continuing to grow, and human cognitive capacity is remaining the same. And then I gave one example out of dozens from my own career where I was more successful by applying human-centered techniques, by taking a class in HCI and learning how to apply that technique, not just doing all math, all computer science all the time. And finally, if we look at practical data scientists, how they're working in business and industry and in science and throughout the world, humans are touching the data throughout what appears to be a kind of clean, well-scrubbed, automated process. We cannot get away from the fact that humans touch the data, and the data science is human-centered. So to conclude, I just want to finish by saying that I want to have a human reach out to you as one human, one woman to others, and say that so often as you're making the decisions for your career, and for your data science itself, you cannot separate yourself from emotions. The amygdala, which is the emotional center in the brain, has been shown to be the area where decisions are made. You cannot make a decision without emotion. And emotions are really a great deal of what makes us human. Now, some emotions work for us, like our curiosity, and some work against us, like our fear. And I want to emphasize that if you are afraid, think about it as coming from external forces, from societal forces, and do what you can to develop a practical way to overcome your fear, because we, as everybody else in this conference has said, we need more women in data science. And I really, really hope that all of you will go on to have tremendously successful careers in data science and that you will believe in yourself. Thank you so much for having me today.
Hey, everybody. So if you have any questions for Cecilia, please add them to the chat now, and then we can start answering.
I hope you don't mind if I do a little bit of self-promotion for my book. This is my memoir that was just released in September of 2020. And it really is about it's all about overcoming fear. It's kind of hard to believe that I was somebody who was I was afraid of doing everything, and I didn't think I was smart enough. I had no confidence in myself. And the book talks about how I went through and gained that confidence, and I don't talk as much about actually doing data science. You'll have to read my technical books for that. But hopefully it is a fun read for people. And please connect with me on Twitter and on LinkedIn. If you're a real person and a data scientist, I will connect back. All right, I think some questions have come in.
We do. Cecilia, can you, we have a couple. Can you talk about the pros and cons of working industry and academia as a data scientist?
Okay, great. I love this question. So I started out in industry mostly because I didn't think I was good enough to be in academia. But I found, the fact is that industry requires just as much intellectual capacity and creativity and, kind of confidence as academia does. I personally like academia better because I like working in the nonprofit sector. I found that, working in industry was really cool and I was solving fun problems, but after a while so I did a lot of work in financial data. And I thought, oh, what am I doing here? I'm, helping bankers count their money. And, that's important. I mean, we need banks. We need to have our financial system running. But for me personally, I kind of wanted to do stuff that, had to do with, that was a little bit closer to, making the world a better place. However, I will say this, I took a big cut in pay when I moved into academia. So, there are definite advantages to working in industry, and you can also have a great impact, especially on ethics. You can push back against the idea that all that matters is the bottom line, is the profit. Profit is important, but it turns out if you look over the long term, profits tend to be higher if you think about societal impacts. For this quarter, you might make more profit just by being technology focused. But if you think about the long term, the companies that are more diverse, that have more of a human-centered focus, that have more women in the C-suite, end up being more profitable. So but what I like about academia is I can look on a larger time frame. I got kind of tired of, dealing with bosses who, I would say, I think our company needs to do this in 5 years. So I worked at DEC, Digital Equipment Corporation, and I said, our company really needs to do a certain thing in 5 years, because I think this will be a growth industry that will bring in millions of dollars to the company. And my manager very nicely patted me on the head and said, oh, Cecilia, that's a little far out. Well, 3 years later, I was proved right. And 5 years after that, the company went out of business. So academia is great in that I can think about things that are going to happen 10 or 20 years from now. And that is another thing I would like to point out. I started working in data science before it was a hot field because I thought it was going to be important. And so I would like to tell all of you out here now, if there's something you think is important, even if it's not hot, learn about it, because I can guarantee you that the jobs in 30 years are going to be different from the jobs that are available now. So keep that in mind. All right. So
next question for you, Cecilia. How do you think being a woman in data science is beneficial to your career, if at all?
Oh, okay. So it's been beneficial to my career, because one of the advantages of being part of a marginalized group is you have both an outsider's and an insider's view. So I always was able to see things both from the outside view and from the inside. And that really gives you tremendous strengths. I mean, even though it's really kind of painful. I mean, and very often I wasn't hired. I even had one person tell me, well, women don't have the intellectual capacity for computer science. And a hiring manager once told me, well, we were really looking for a young man. And then there were all the more subtle things like, when I got interviewed at certain large technology companies, when it was really clear they didn't like hiring women or Latinas. But there always are good people out there who will hire you, and you know what? You're going to make their company more profitable and better. So, so it's a tremendous advantage.
So next question. I know we're kind of running out of time, but we might have time for one more. What is Cecilia seen as one of the ways a woman can be heard during meetings with male leaders and data scientists?
That's a wonderful question. All right. So first of all, yes, when you speak, people will not hear you very often. So what you can do is you can find allies. This is something I've done very successfully. I find allies in my company or in academia, and I say, I've noticed that nobody hears me when I speak up. So next time I speak, could you please amplify what I say? And if a man amplifies what you say and gives you credit, not just repeating it as his own idea, and says, thank you, Cecilia, for making this excellent point. I completely agree. And then repeating it. And the other thing is just sometimes I have to repeat it. We have to be outspoken. And again, this is where my learning to face fear helped me, is I learned, if I can point my airplane at the ground and risk death, I can speak up another time, even though some of the men are rolling their eyes. And I know it has made it harder for me to be promoted sometimes. But the fact is, this is why I love science and data science, is because in the end, the data will speak for you. And so the other thing I have done is I've done a lot of evidence-based arguments. I spent a lot of time talking about the data and explaining how it justifies a human-centered approach. And you know what? People do listen to that. And I've actually had multi-million-dollar groups started because I convinced them through the use of data that a human-centered approach made sense. So yeah, so keep doing it.
Well, I hate we have so many more questions, but we are hitting our time. Thank you so much, Cecilia, for being our keynote for this afternoon and kind of rounding out the WID Charlotte conference. We really appreciated it. It was such an inspiring talk. And thank you everybody who attended today and the conference in general. We really appreciate having you. We do this for you guys.
Yes.
Have a great weekend. And again, thank you.
Have a wonderful weekend. It was a real pleasure to talk to you, connect with me.
Yeah.
And yes, this is a great conference. Thank you so much, Katie and Yeniko and everybody. Thanks to the audience and thanks to the sponsors. This is a fantastic experience.
Thanks, guys. Have a good weekend.